I'm Pete Zielinski, an editor with Modern Machine Shop magazine. Engineering change orders can be a headache or an opportunity, depending on your point of view. How do you look at these changes? Today's webinar is titled Engineering Changes Made Easy, brought to you by Cimatron Technologies. Our presenter is Cimatron Support Manager Dan Branch, who will describe how winning shops are mastering engineering change orders. As Dan speaks, please feel free to ask questions. To submit those questions, use the question pane at the right of the screen. We'll receive those, and at the end of the presentation, we'll answer as many as we can. Also, this webinar is being recorded, and you'll be receiving a link by email so that you can share this presentation with others. So with that out of the way, Dan, if you're ready, please begin.
Thanks, Pete. Little word about Cimatron before we begin. We just this year celebrated our 30th anniversary, and our specialty is CAD and CAM for all kinds of tool making all over the world. We actually have quite a large global presence with...
Welcome to GoToWebinar, Web Events Made Easy.
Really, it's anywhere that parts or tooling is being designed or built. This slide represents the results of an independent benchmark study that was conducted, where mold delivery times were tracked. And what it shows is that you can see the shops who chose Cimatron were found to be the best, even outperforming a group that they had termed as best-in-class tool shops. So today, what we're going to show are some strategies for dealing with engineering changes. These don't have to break a job or destroy the timetable. And it all starts by precise analysis of the incoming revisions. The new data has to be known, and it's also very important that we keep it separate from the changes we may have made to the parts ourselves. So we'll look at that. Next, of course, we have to implement the change. This is where we'll spend some time today. Because these options are important to look over, and there's quite a few. And lastly, we want to look at a bit of functionality for tracking and organizing the changes as they come in. So let's look deeper, and we're going to start with the definition of an ECO. We use that term here a lot. It's the one thing you can count on as a mold maker when you take on a new job, is that there will be some changes to the design along the way. It's really just an accepted fact that engineering changes are going to happen. And the mold delivery times are shorter than ever, so these have to be seamlessly phased into the mold design, even when it's close to complete. So this has been a long stumbling block for the business, and they can really throw a job off its delivery date. So what we'd like to show today are some new tools for processing ECOs that can mean a lot fewer headaches later on. To set the stage for talking about engineering changes, we have to recognize that the process of designing a mold has several steps. Everything, of course, starts when the plastic part data is received, but then the mold designer begins working on that data, breaking it down into groups that have a pull direction. Then parting surfaces between these groups must be defined, and eventually they become the cavity blocks and slides and everything else that's needed to mold the part. And the mold design process continues with the addition of plates and all of the other standard components needed for a functional mold. And at some point, the mold design is finished.
Muted.
The mold shop can tell you the concept of a finished mold design is a constantly moving target. The compressed delivery times of the business mean that while the mold design is being done, the part design is also continuing to evolve. And changes to the part may come often, even daily. So these changes have to be implemented as quickly and as accurately as possible. That represents a tremendous challenge for the mold designer. In many cases, when the new part data is received, it may not even be clear which areas have been modified. And so the initial task is to compare the latest data to the working model and find every difference. So we'll look at this. A CAD system for tooling has to provide this functionality. Too much is at stake to rely on anything less than a precise overlay of the exact 3D models that are in use. Now, once identified, there still remains this huge task of implementing the change into the ongoing design. Really, the initial part data is at the top of a large pyramid, and the entire assembly has descended from it. So a top-down approach, where each successive part updates the changes above it, would seem the best plan of attack. And often it is, especially at the early stages of the mold design. Regenerating associative parts in an assembly is a very useful ability. But having only one option is quite limiting. Part changes often affect parting lines, they add slides, they remove lifters. These tasks require new decisions and input from the designer. Regenerations in large assemblies can take a very long time. They can cause unanticipated failures. And in very large molds, there may be multiple designers or completely lost feature histories or other roadblocks to updating down through. So the CAD system must provide optional paths for implementing the engineering changes into the existing design assembly, perhaps at the parting level, or even directly down into the cavities and the other plates. But no matter what, we still have to do this as fast and efficiently as possible. So because there are likely to be many engineering changes, the CAD system must also help keep track of them all. You want to be able to see the differences between revisions and know when they were received at any time. And you want to know when the changes are complete in the design models. Well, it's time. I would like to demonstrate some of these best options we have for handling engineering changes. And I'm going to do that by using the latest version of Cimatron E, which is version 11. So on the screen, what we're looking at here is the early stages of a mold design assembly. I have a tree on the left that shows the structure that will eventually hold all the mold plates and components for the main systems of the tool, and also an area where I can work on the plastic part itself. We're going to talk today a lot about the work part. What Cimatron calls the work part is a direct import of the customer data. This is a copy the mold designer can work in. It gets scaled up for plastic shrinkage, but that won't be the only change the designer is going to make in this part. He's going to make surfaces to split and develop new parting lines. Often draft is added or sizes can be adjusted for tolerance. So there can be a lot of effort spent here. And these preparations for molding present the first big hurdle when an engineering change comes in, because they don't exist in the customer data, but yet we have to maintain them through each new revision. Using our quick split function, we can see that this part required a slide, and a new parting line was developed to split those customer faces. Most of the parting here has been designed now, except for a small area where a lifter is needed. So we're definitely in a partial design stage here. The general principle in Cimatron is going to be to analyze all the engineering changes directly in this mold assembly. So to do this, a special tree can be added. It's just to store and view the analysis results. If I right-click in this tree, I can see that I have access to the functionality we'll be using here today, and this is for processing and analyzing the changes. In fact, it might be nice to make the very first analysis we're going to do between the only two parts that we have so far, which are the original data from the customer and this file of ours, the work file. A comparison between these two files will illustrate all those minor tweaks we've just made to the part to facilitate the molding. Well, any part we want to add and run analysis on has to be brought into the assembly. And adding a part for comparison really couldn't be easier, because we can position it on the screen using the reference model that we've already made. So you see there, the existing work part automatically supplies the orientation to overlay any new revision, and it's also supplying automatically the scaling factor that was used. So we don't even need to know what that was. It's there by the click. And now we can run our first simple comparison. So between these two models, what we're going to see is that Cimatron uses a color display to illustrate the differences between the two parts. The most noticeable colors right away are the wireframe edges. We have a little dialog here. We can turn things on and off between old and new. There are two things to note in the part I want to point out here. One is where the work part did split the faces around the slide. So that was part of what we did here. And the other is that the 6 holes we're looking at have been modified a small amount, because they're now on the high side of tolerance to be steel safe, and we did add some draft in these areas too. The vast majority of the part, though, is unchanged, so using the dialog again, we can hide that away. This lets us better see that the modified surfaces are really kind of a red and blue color. The coincident faces are actually a third classification in the dialog. These are the surfaces that haven't been moved, but they have a different trim boundary in the area of the change. So we call those out separately as well. Anytime you're done with the analysis, you save it. It is kept in the tree. It has a name that describes it. We can turn anytime things on and off. We can once again just look at the wireframe that showed where the changes were. Okay. Well, when the inevitable happens and the first ECO arrives, there's really no need to worry about where the design is and how far we've progressed. I'm already waiting for ECO 1 in this tree we've created. And now I can browse out and really pick up the first customer change for revision 2. So let's add this one into the assembly. And again, we'll just use the work part to supply the location and the plastic shrink value for it. So in this first example, this first change, what I want to talk about is that top-down approach for bringing the new data in right at the very top step of the design. So because of that, when I do the comparison here, I'm just going to use the old and new customer data files. Nothing about the existing mold design yet. The comparison uses the same color display every time. And now what we can see here is that this revision consists of a new rib and also a slight movement of an existing rib. Turn off a few things. So also over here what we'll see is the diameter of this hole is changed, and that is going to have an impact on the parting faces that we've already made for that area. So with the comparison done, we can really choose how we're going to implement it. And for this full top-down update that we're talking about to begin with, Cimatron has a pretty amazing new concept. It's called Replace Master. We can see what this is going to do even before we try it. If we go over and check the work file, we can see that its original import was a file called handle. This was the very first customer part data. What Replace Master is going to do is it's going to break this link and it's going to substitute the newly received part. Well, that would normally be a disaster for a typical CAD system. Every bit of effort that we've done here that the user has made in the design hinges on that original data import. So I mean, just because the new part looks similar doesn't change the fact that it is a completely new file, perhaps imported from some other CAD system. The natural expectation then is that all the features we've built so far are going to break down and fail. But Cimatron can pull off this trick. Okay, so the regeneration that we're going to see happening there on the bottom of the screen, that's all the mold design activity so far being linked over to the whole new data file in a fully associative way. We can see there the input to the work file is now actually the Rev2 part, and all the existing features that were there now look to that. Even in the parting surfaces, if we go around to the slide area here, what we're going to see is that the slide area understood the new input, the surface features that the users created, and it's already recreated it from this larger circle, which is kind of amazing to me. Now there may still be a little cleanup to do. We can go back to Quick Split. We can check what's left over. Actually, a lot of this latest geometry has been assigned into the correct sections of the mold design even. Just a bit of rib geometry left over that we can assign. We're right back where we started now after revision 2 has been implemented. I'm going to go back to this slide just for a minute, because we want to talk about that top-down again. These top-down updates, they're great. But as good as we have made the new tool, again, they do involve regeneration in CAD. And that's through potentially huge long lists of feature trees, not like we're showing here today. And really for all those other reasons we mentioned earlier. What I want to do now is switch to talking about some other options, the ones that you really need to have there for you in the toughest designs when time is of the essence. Well, back in Cimatron, the tree allows us to create a separate folder for any analysis we might want to run in conjunction with ECO2. And let's add a new part. The second change has showed up, we'll say. And once again, we're going to overlay it into the design assembly with automatic position and scaling. Okay, well the idea from here on out then is that we're going to apply whatever new changes we get directly into the design at the current point of working. When we go that route, the comparisons are always made directly against our work file. After all, the work file is what distributes the part data down into the mold design. It's the model that is the customer part in the as molded state. Okay. So we'll run this analysis. And the results of this comparison are going to show the changes, but we've got one pesky problem here. Those part tweaks that were made in the work model to facilitate the molding, they're something we always want to keep. But if the data from the customer doesn't include them, the comparison shows these areas as geometry to be replaced. And we can't have that, but we can actually fix this situation right in the comparison, because we can apply a third part into the analysis. So by doing this show changes from previous, we're going to apply a filter. Only the changes that are found between the work part and the new revision that are also changes between the last two customer parts are now being shown. It's a really neat idea because those part tweaks aren't part of either of the customer data files. They're filtered out of the picture. what we really see is the difference in the changes, but not just between the two. We're still taking the work file into account. So with that correct new geometry identified, we can get on with implementing this into the mold design. And this time the choice is going to be to replace faces. As the user needs to do nothing extra in this case really, we're going to confirm it. The work file was already set up to be the receiving part when we did the analysis. And replace face is merely letting us confirm the geometries that are being added and removed. So that makes the switch for us. We go back to the work file. What we see here, let's only show that, is that the new geometry is now added in. It's at the bottom of the tree. Once this newest data is added in, we'd go to Quick Split, we'd assign into the correct set, and we just get back to work. Okay, what I'm going to do now is open up a later assembly so we can look at this a little deeper. In here, the mold design has progressed. We've included other components. We've worked on cavities. In fact, the last task was adding a standard core pin in here. And, strong catalog and cutting tools are really one of the reasons Cimatron has always excelled for tool design. Something like a small assembly that we need for our slide. I can go out and look in the catalog, and I can grab just what I need. It's easy to select. It's easy to position stuff in the tool based on faces and points that we're working from. And we've got a parameter here with cut. So that's going to create all the pockets and the screw holes. They come right from the cavities. And of course they follow along as the parts may move later on too. While I was working on this core pin, that actually still needs some shape to be complete. It's actually pretty easy work in Cimatron because we always reference right back to the work file that holds our part data. And we have cutting functions that are specifically made just for cavities, for lifters, for inserts like this. Well, this seems like a good time for another engineering change to show up. They usually do. Like before, this is going to require another folder in the ECO tree. And we're going to add our new part for comparison purposes. Okay. So the comparison again is going to show the two parts that we are comparing against. And again, it's showing those unique features that we made to the part for molding. So we're going to want to filter those off one more time. And when we get the result we want here, we're going to see that basically this time the change involves not only some features of the part, but it's also affecting the shutoff that we have designed. But in this case, again, we're not doing the top-down approach. So let's accept this. And like before, let's use that replace faces command to make sure that only the new geometry gets moved into our work file. So there it is. Now I'm going to be sure to organize our new data, and we'll use Quick Split for that. Actually, let's edit the existing pull directions that we have. This is a nice ability to say, all right, we were already going in that direction. Just check it again and see what's new. So we'll do that for both sides. And it picks up all the new data. Now remember, the idea of implementing these changes lower in the design is to avoid the regeneration of features. So if I was to show the shutoff faces, what I'm going to see is that these have not moved in this case. But that's the expected result. Old features do not update, but nor do they fail or even really matter. The new data is just brought to you, and you simply fix whatever needs fixing. So designing shutoffs is one of Cimatron's many strengths anyway. It really presents no problem. Let's see. Get rid of what we had here. And we're going to use a face command called cap internal islands to fill in where the new area is. And we'll get the natural extensions that you really ideally want on a contoured face like this. Make sure those are known as parting. And everything looks good here. So what you could really say for this third change that we're doing, this third ECO, is that we've chosen to implement into the middle of that design pyramid I was showing you. The new change is in the work part, no feature regeneration, but it's not down in the cavity and core. So really in the middle case here, the regeneration of features hasn't totally been avoided, but it is a much smaller and quicker regeneration that we need to do because we only need to get the mold components and run the update there. This already implements anything new that we've got in the parting area. Let's see how that goes. You see we've still got the old geometry here, but we edit and accept the feature that brought the geometry from the parting. So that would be the implementation of ECO3. We can right-click, as we've been doing here, and we can mark these done. And it really brings me to my last option, dealing with engineering changes. This is the option that we would use for whatever reason when we want to completely avoid feature updates. Completely. So essentially what I'm saying is we want to take the new data and glue it directly into the bottom of that pyramid, the bottom of your design at the component level. So to prepare for that, we've already marked the third ECO as done. I'm going to create a new folder for ECO4. And as we've done before, we need to add the latest part data in. Now the new data, of course, is what's supplying the changes. But we can set up for this receiving part anything in the design assembly, not just the work file. For example, we can set up core block to be the receiving part. If we were to run the analysis so far, though, you're going to see that a great deal of the result is not right. We're only looking at these two parts, so much of the geometry that's found is different. So this is the case if you're applying it right to the cavities where this filter is very important, the one that considers the previous part level. Okay, now we can really see the more relevant changes that are just from the latest revision. But we're only working on the core block at the moment. So what we really need is even more filtering required. The new changes that we're seeing here affect the core and the cavity. And we're just trying to bring stuff into one. So if I would just replace faces, I'd be adding many more surfaces into the core than I really need. I'm still going to save this analysis, though, because we can always come back and rerun these anytime we want to. But what I'm going to find worthwhile on this last example is just to do a little bit of prep work on the latest part. We need a way to tell that analysis function, the compare, which surfaces belong to just core or just cavity. And that's actually pretty easily accomplished using the function Cimatron users are very familiar with, which is quick split. So acting right on the new part, we're going to do a very quick check to find the main groups for core and cavity. It's not really necessary to analyze every little surface here. You just want to get the main group separated in the areas where the change is going to be. And once that's accomplished, we're going to go and back to the existing comparison and edit. So remember, these are the results we saw a moment ago. But what we're going to use here is an optional step. And this optional step exists for manual interaction with a comparison result. For example, I could just unpick one of the faces from the new revision that I didn't want to implement. But in this case, we can do a lot better than a manual selection, because I can ask the system to take away any faces that are not relevant to the set and to the block I want. So now the results we're seeing are only the ones applied to the bottom set, the core block set. Once again, we're going to use replace faces, and the receiving part, which is the core block this time, is going to get this new data. Okay, the revised data is clearly in place. It's added as the very last feature in the tree. The goal of avoiding any feature regeneration is completely achieved in these cases. What all that remains to be done is really just check the core block. It depends on the nature of the change. Much of the new shape is already finished here, but where a parting line is affected, we should really make one last check. So fixing the shutoff in this case just involves trimming one of the faces to the new boundary. And that would appear to be all that's needed. But you know what? There's a way we can know for sure. These comparison tools that are so useful for finding initially the changes, we can also use those to verify that they've been implemented. So if we look back to the ECO tree, we've been seeing here that one of the parts involved in the comparisons have been changed. That's these little marks, these exclamation points. And it's obviously the core block. It's the one we just worked on. If you want to, you can update these comparisons to the current state of all the parts involved. You can do that. So anything that still shows up would mean that there was still a difference found. And we're pretty good here, but in this case I am seeing this small edge in the blue. I think that's just an edge that didn't stitch up in the core between the old and the new. It's maybe a tiny gap that I should check into, but the system is helping me understand that. So it's a way of checking the implementation level. And of course, with this revision, we'd still have to do the cavity in the same way before we'd be truly done. But this sort of wraps up the high points that I wanted to show today. I am missing one little function in the version I'm using, but I'm going to show you that as we conclude here. So what we call ECO document is optional, but it's something our users seem to like so far. It's not a function. It's just an internal document. It's a place that can be used to store a description or pictures of the engineering changes as they come in. Any sort of comments on the status you can keep in here, and anyone in the company really can come to this one central spot and get an idea of where the implementation stands. Brings me to highlights. So what I've hoped to demonstrate today is kind of an exciting new solution to the complex problem of coping with engineering changes. You saw our latest method for making overlays as the data is revised by the customer, and how the changes can then be phased into the mold design with options that always give a quick solution, no matter what the path the designer wants to take. And we saw how the changes were organized into one central tree structure for maximum efficiency there. And at this point, it's time for your questions.
Well, we do have some questions. And again, if you haven't asked your question yet, the question pane at the right of your screen, just enter it in there. We have some that have come. Dan, these first couple, I think, relate to the volume of changes. The question asks, is this a process that can be used over and over again, no matter how many engineering changes come along?
Actually, Pete, it is. We did quite a few here, but the whole structure that we put together is, yes, designed for no matter how many changes come down the line, you're going to be able to implement the same strategy over and over again. There's no limit, certainly.
Another question is kind of similar to that. Will the assemblies get too large if all of the revision parts are kept inside it along with the mold design?
Yeah, that was actually one of my first concerns too about this. It's possible. We've got some customers that do very, very big mold designs, automotive parts, huge stuff. And yeah, we're keeping the part revisions in the main assembly, but they don't have to stay there. After implementation, after we've done our check, you can suppress those. And I don't think it's going to be a problem. You can, by suppressing the parts afterwards, you can really keep the assembly size at a minimum.
The next question says, why not use the top-down approach on all changes?
You know, you could. There's no reason to say that you couldn't, other than the fact of, you know, what we tried to discuss here, which was some people just don't like to. Some people don't get into the weights and the dealing with regenerations. Features can fail because of the changes. I mean, the changes are going to be in difficult areas. So I would say to a user, you should try it that way, the top-down approach. But as the molds get more mature, as we've worked on them for maybe into a week or two, things get long, and that's where the other options come in very handy.
Couple more questions. I guess this one gets at how new and different this really is. The question says, can other software solutions out there do what Cimatron can do for ECOs?
Well, I don't know exactly, but I do know that Cimatron is unique in a couple of different ways. How we deal with incoming data as valid geometry, whether it's open, closed, whatever. These solutions are really built to handle the change that comes either internally or from outside. If the history is not there, we can still deal with it. I don't think that, no, I don't think a lot of softwares can do what we do in this regard at all.
Another question says, is ECO a further add-on from Quick Compare?
It's different than Compare, but as the user probably saw, the Compare engine is what's inside it. I forget how this is packaged, but even my customers out there using version 10 have a version of the ECO Manager and versions before 10. So if you had all that stuff, you have this stuff in E11 when it comes out.
This question says, once you have done a change at the insert level, is it still possible to go back to the top and change the work file again?
Yes. Here's the thing. I showed our options in a certain order. Started with the top down and kind of talked about, well, let's put a change in the middle for various reasons, or let's put a change in the end. Once you sort of move down that list, you really should stay there. And I think it's kind of obvious. If you're taking a change and you're comparing it to the work file should always be up to date. But if you're moving it down into the bottom of an organized tree, of a history, it's a bad idea then to say, well, for the next one, let's shove it in at the top, because it's not going to recognize that new geometry until the end. So you can mix and match, but if you go in one direction, you really should stay with the last option you picked.
And here is what looks like it might be the final question. Do you have to have, excuse me, do you have to have your parts quick split in order to use ECO Manager?
No, you don't. You saw me using it a lot, but because quick split is so involved, it's so vital to the process of how we pass stuff down into cores and cavities. I mean, that's how we know what goes to what part. Is it assigned to the blue? Is it assigned to the pink? Or many of the other sets. And so in the cases where I wanted to update, I needed to do that. So it knew where to take what surfaces. If you're really applying these changes right into the bottom level, like the last example we saw, there's no reason why you'd have to use it. But you may get a little more extra data than you wanted. That was part of why I was hoping to show in the last one there, where we use quick split to just say, all right, for this block, this comparison, we really only want to look at the bottom of the part. And so quick split's a very quick, I guess, way to filter off some of the parts. But no, not necessarily. You wouldn't have to use it.
Okay. A couple more questions have come in that I don't think we'll get time for. I apologize for that, but I want to thank our audience members for joining us, and thank you for some very good focused questions that have come in. It's something to think about. How effective is your process for fulfilling engineering change orders? As I said earlier, a link to the recorded version of this webinar will be emailed to you in a few days if you'd like to review this again or share it with others. In the meantime, thank you to Cimatron for providing this information today, and thank you for giving this presentation your time. Have a great day.